On behalf of the SCSTE, I would like to welcome all viewers and especially our dear students to this online class. And today in this class, we'll be doing a new chapter, which is chapter 9, and the name of the chapter is Some Applications of Trigonometry. So let's begin. So in the previous class, we have learned about the concept of trigonometry, angles and trigonometric ratios. And now in this chapter, we will use trigonometric ratios to discuss some problems regarding height and distance. But before we go into such problems, we will look first at three new terms, and those terms are: number one, line of sight. First, let me write down the definition of this term. When we observe an object P from a point O, then OP is called the line of sight. So let me explain to you the meaning of this term. Suppose we are standing at this position, alright, and suppose we are observing an object which is somewhere here. Suppose that object, we name it as point P, alright. Then the line of sight is nothing but the line between our eyes and the object, alright. So this line is called the line of sight, alright. So now let's move on to the second term, which is called angle of elevation. Let me write first the definition of this term. If from a point O we observe an object P which is placed above the level of our eye, then the angle which the line of sight makes with the horizontal line through O is called the angle of elevation. So let me explain to you the meaning of this definition. Suppose we are standing at this position, and suppose we name this position as point O, and this will be the horizontal line to the point O, alright. And suppose we are observing an object which is placed above the level of our eye. Suppose we are standing in this position, then this will be the level of our eye. And suppose the object is placed somewhere here, and we clearly see that this level will be a level above the level of our eye, alright. And so when we observe this object, then this line will be the line of sight, and this angle which is formed, alright, by this line of sight with the horizontal line is called the angle of elevation. So this angle will be the angle of elevation. Alright, so now we'll move on to the third term, which is called the angle of depression. let me write first the definition of this statement. It's similar to angle of elevation if from a point O we observe an object P which is placed below the level of our eye, then the angle which the line of sight makes with the horizontal line through O is called the angle of depression. So the angle of depression is similar to the angle of elevation, but in this case the object is placed below the level of our eye. So suppose we are standing in this position, and suppose we name this position as point O, and this will be the horizontal line through O. So let me name it as OA. So when we look at an object, or when we observe an object which is placed below the level of our eye, this is the level of our eye, this is the level above the level of our eye, and this is the level which is below the level of our eye. So when we look at an object which is placed below the level of our eye, suppose this object we name it as point P, we are observing this object from this position O. So this line OP is the line of sight, and this angle which the line of sight makes with the horizontal line through O is called the angle of depression. Alright. This will be the angle of depression. And so now we will use the idea and the knowledge of trigonometric ratios and these three new terms which we have just defined to solve some problems from exercise 19. So before we solve this problem, first of all, we'll try to draw a diagram, alright, which describes all the given information described in this question, alright. So first let us draw that diagram. So there's a tower which is 103 meters high. So first of all, we suppose this line to be the tower, and this is 103 meters high. And so we have to find the angle of elevation of its top. This will be the top of the tower, and this will be the foot of the tower, from a point 100 meters away from its foot. So we consider this point to be lying on the left side, alright. You can also consider the point to be lying on the right side, you will get the same answer. So if I consider that point to be point O, then this will be the line of sight, alright. And so this will be the distance, alright, of the foot of the tower from that point which we are observing, alright. So first of all, let's mention the diagram properly. We mention the tower to be AB, and in this point which we are observing, we are taking it to be point O. So first of all, let's describe the diagram properly. So let AB be the tower and O be the point in which we are observing So according to the question, we already have the height of the tower to be, which is AB, 100 root 3, and we have the distance of the foot of the tower from this point which we are observing, it is 100 meters. So it will be OB is equal to 100. And so now we have to find this angle of elevation. Because this is the line of sight, this is the horizontal line through O. And so according to the definition, angle of elevation is the angle which the line of sight makes with the horizontal line. Alright, so this will be that angle. And so this is the angle of elevation. So let us mention that also. So let us write, let theta be the angle of elevation. Alright, now according to the concept which we have done in the previous class, we can either use these trigonometric ratios, sine of theta, cos of theta, and then tan of theta, cosec of theta, cot theta, and sec theta. But we have to choose these trigonometric ratios properly, alright? Because if we choose, suppose we choose sine in this case, then we know that sine theta is perpendicular by hypotenuse, but we see that the information on the hypotenuse is not given, alright? We can find out, but still it will take a lot of time, so we use the proper trigonometric ratio. And in this case, since we already have the perpendicular and the base, alright, so we can just choose tan of theta. It will be much simpler, alright. So, tan theta is equal to, now we see that we have to remember the perpendicular and the base depends upon the angle in which we are considering, alright. In this case, we are considering theta, so it is angle AOB. And according to this angle theta, alright, we have the perpendicular to be AB, because this line AB is opposite to this angle, so this will be the perpendicular and this will be the base. So we have tan theta is perpendicular by base, so it means we'll have AB by OB implies tan of theta is equal to, then we already have AB to be 100√3 and OB to be 100. 100√3 means 100 into √3, so that means we can cancel out. Alright, so we'll get only √3 implies tan of theta is equal to √3. Then we clearly see that theta is an acute angle, which is an angle less than 90 degrees. So that means according to the concept which we have learned in the previous class, we will have theta to be 60 degrees. Alright, so now let's move on to the next question. So in solving this problem, we'll have to mention a diagram, alright, and that diagram should contain all the information given in the question. So let's draw that diagram. Suppose we are considering this to be the lamp post, alright. So we have a 1.5 meter tall boy. Suppose that boy is standing in this position, alright, and this is the height of the boy, 1.5. So because this lamp post, alright, is giving up light, and so we'll have a shadow, alright, of the boy, and that shadow will be cast on this side, alright. So let me draw that. So this is the lamp post, and this is the boy of height 1.5 meter, alright, and the shadow is cast, alright, which is this one. Let's mention, we'll mention the diagram properly later, Alright, and that shadow, alright, let's look at the length of that shadow and cast a shadow of 4.5 meter. So the length of this shadow is 4.5 meter. So that's all the information given. And also we have that 3 meter from the lamp post. So this boy is standing at a distance of 3 meter from the lamp post. So we see that the distance is not properly, so we'll draw the diagram a little bit in a proper manner. This is the boy. This will be 4.5 meter and this will be 3 meter. So now we have the lamp post, the boy, and this is the length of the shadow, and this is the distance of the boy from the lamp post. Alright, so now let's mention the diagram properly. We choose AB to be the lamp post, let CD be the height of the boy, and then DE be the length of the shadow of that tall boy. So now let's mention the diagram properly. Let AB be the lamp post, CD be the tall boy, and ED be the length of the shadow. So according to the question we have, AB is not given, we have CD to be 1.5, which is the height of the boy, and then we have ED, the length of the shadow, to be 4.5 meter, and we have the distance of the boy from the foot of the lamp post to be 3 meters, so we'll have DB is equal to 3. Now we'll have to find the height of this lamp post. Alright, so now we'll use trigonometric ratios again. Alright, so now we have two right angle triangles, this one CDE and ABE. Alright, so we can choose any of them first. So now let me choose first the smaller right angle triangle, which is triangle CDE. So in triangle CDE we have, so we'll choose that trigonometric ratio which will give us the proper values of the information. Alright, so we can choose tan of angle CED. This is the angle CED, because if we choose tan of angle CED, then we already have the information 1.5 and 4.5, so we can use them properly. So tan of angle CED is equal to perpendicular by base. So with respect to this angle, this is the perpendicular because it's the side which is opposite to this angle, and this will be the base. So we'll have CD by ED, which is equal to 1.5 by 4.5, and we can simplify this one. We'll have 15 by 10 into 10 by 45. So we can cancel out 10 and 10 will get cancelled out. 5 3 15, 5 9 45, and then 3 1 and 3 3. So we'll have 1 by 3 after cancelling out. So implies tan of angle CED is equal to 1 by 3. So we mention this as equation 1. Next we'll use the other right angle triangle. So we have the other right angle triangle to be triangle ABE. So in triangle ABE, we have, because we want to find the height of the lamppost, alright, which is AB, so now we'll use again tan of angle AEB, alright, because the base is given. You see, we clearly see that EB is nothing but ED plus DB, and so we already have that information, so we can use that. So we'll use tan of angle AEB. And with respect to this angle, this will be the perpendicular and this EB will be the base. So we'll have AB by EB. And so we'll have, AB is not given, so we just write it again as AB. But EB is ED plus DB, so we can add 4.5 and 3, we'll get 7.5. And so we have tan of angle AEB is equal to AB by 7.5. But we clearly see that from equation 2 and from equation 1, angle CED is the same as angle AEB. Alright, so that means the right hand side of equation 1 must be equal to the right hand side of equation 2. Alright, so we can conclude that AB by 7.5 is equal to 1 by 3, and so we just multiply by 7.5 on both sides, alright? So 7.5 and 7.5 will get cancelled, and so we'll have 1 by 3 into 7.5. So that means we'll have 2.5, which is the required height of the lamppost. So I'll be stopping here today for this class, and we'll meet again on the next online class. Until then, stay safe. Thank you.